This is the question number 1 of paper 2017. There is a venturimeter given in which the flow rates, two flow rates are given, that is Q1 and Q2. For the flow rate Q1 there is a corresponding pressure drop in the venturimeter, that is delta P1, and for the flow rate Q2 the pressure difference across the 2 points, let's say A and B in the venturimeter, is delta P2. So the two flow rate that are given in the ratio of Q2 by Q1 is 2. So we have to find the ratio of the pressure drop, that is the delta P2 by delta P1. Suppose we will make the diagram of venturimeter for the better understanding. Something look like this. And for the first case, there is a flow rate, for example Q1, and we know the manometer is attached to measure the head loss between the 2 points, that is A and the P. For the manometer liquid, for example, this is the manometer liquid. Okay, so for the flow rate Q1, the head loss, or say the pressure drop between point A and B, let's say delta P1. And in the second case, the flow rate is Q2, and for the same manometer there will be some difference in the liquid level corresponding to some pressure difference. Suppose this is the liquid 2, so there will be a height difference corresponding to that. There's a pressure difference, that is delta P2. So we know that from Hagen-Pastula equation, delta P is equal to 4FLV square upon 2D. So for the first case is velocity is V1 and delta P, let's say delta P1, and for the second scenario delta P2 is the pressure drop and velocity will be 4FL, V2 will be the velocity upon 2D. So there in the question something delta P2 by delta P1 is given. Delta P2 by delta P1 is given as, we have to find that delta P2 by delta P1, and Q2 by Q1 is given, that is 2. We have to find the ratio of these two pressure difference, so we can simply take the ratio of both these equations. So V2 can be written as Q2 upon area, and V1 can be written as Q1 upon area. So delta P1 will be something like some constant, let's say C. F will be the constant D24L, because its length is constant for both the scenario. P is some constant times. V1 can be written as Q1 upon A will be the some constant, A square again constant, that will combine with the C to make the new constant. So delta P1 is equal to Q1 square, and the same scene will be in the scenario 2. Delta P2 will be some constant C, Q2 square. So we have to find delta P2 by delta P1. So we'll take the reciprocal of equation 2 and equation 1. So delta P2 by delta P1 is equal to Q2 by Q1 whole square. Q2 by Q1 is 2, so 2 square will be 4. Our answer is option number 2, that is 4.